आज के इस लेक्चर के माध्यम से वेरिएशंस इन रेट ऑफ वाटर डिमांड और फ्लक्चुएशंस इन वाटर डिमांड के बारे में स्टडी करेंगे। वाटर डिमांड वेरीज विद द सीजन, month, day and hour. These variations must be accounted for safe and economical designing of water supply project. These variations are due to seasonal changes, festival and public events, industrial activities, climate changes, etc. We can see during the summer there is more water demand than the during winter for the same day. Now we can our hourly variations in water consumption. यदि this line is annual average daily demand line, annual average daily demand line means the population total consumption of by the population divided by 365. Then there will be from 12 am to 5 am there will be very less water demand than the average annual average daily demand. Then from 5 am it increases up to 10 am. It increases up to 10 am. It goes generally 180% of the annual average daily demand at the peak, and again after 10 am it decreases to minimum at 5 up to 5 pm, and thereafter 5 pm it again increases up to 9, and after 9 decreases up to 10, and thereafter it stabilizes up to again 5 am. So that is how 24-hour cycle of water demand goes. Midnight 12 am to 5 am very low demand, 12 am to 5 am very low demand. Morning 5 am to 10 am highest demand due to bathing, washing, cooking, toilet brushing, etc. Then 10 am to 5 am moderate demand, 10 am to 5 pm there is moderate demand. Evening 5 pm to 9 pm second peak occurs. Second peak occurs between 5 pm to 9 pm, and from 9 pm onwards again there will be very low demand till next day morning up to 12 am, and thereafter it again takes a cycle. So Goodrich has given formula to estimate the maximum water demand in comparison to the annual average demand during the day. Say he has given 180 T raised to the power minus 0.1. Since in this formula if we input 1, P is equal to 180 1 raised to the power minus 0.1, we find 180%. This is in percentage. There will be जो annual average daily demand होगा उसका जो maximum day का demand होगा जो for any hour or during the day, वो single hour हो सकता है, 2 और 3 hour के लिए बना सकता है, that will be about 180% of the annual average daily demand. So that is how we have designed our distribution network, piping system, reservoirs, overhead tanks, or anything to avoid the scarcity of the water during the peak. So pipe में जो pressure है वो कम नहीं होना, pumping भी हमारा बराबर होना चाहिए. So all this, and if we want to know the monthly हमारा जो variation होगा वो कितना होगा, then we can input 180 30 raised to the power minus 0.1. We can calculate, it will come about 128%. So this is 30 raised to the power minus 0.1 equal to 0.71. 180 into 0.711 multiply by 180. So it has come 128%. So monthly variation will be 128%. Likewise, seasonal variation, monthly variation, all this is being calculated based upon the Goodrich formula. And also in standard it has been given maximum seasonal consumption, it is 130% of the ADD, annual average daily demand, and maximum monthly consumption should be 140% of the annual average daily consumption. Maximum daily consumption is seen 180%. Maximum hourly consumption is 150% of hourly maximum daily consumption. Hourly maximum daily consumption is 180% for 1 hour. So 1.8 into average annual average daily consumption divided by 24 multiplied by factor 1.5, then 2.7 into annual average daily annual average hourly demand हम कर देंगे तो we get the maximum hourly consumption that should be taken for the peak. This is a peak demand. सीजनल और इसको कंसिडर करेंगे तो और भी ज्यादा हो जाएगा, बट मिनिमम जो हमारा मैक्सिमम आवरली कंजम्पशन होगा दैट विल बी 2.7 टाइम्स ऑफ एनुअल एवरेज आवरली डिमांड. जो एनुअल एवरेज आवरली डिमांड होगा इसका हम आगे क्वेश्चन भी देखेंगे. और वी कैन सी हियर if a population of city 1000 person consumes 54.75 million liters of water in 1 year, annual average daily consumption 54.75 million divided by 365, it will come 1,50,000 liters per day, and per capita consumption 1,50,000 divided by 1000, 150 liters per capita per day. So that is how we calculate, that is LPCD per liter per capita per day. So once population is given, total consumption is given, we can find out the annual average daily consumption कितना होगा, daily demand कितना होगा. So absolute maximum hourly water demand, हमारी जो वाटर सप्लाई होगी साल का वो दिन जिसपे एक सिंगल आवर के लिए मैक्सिमम वाटर डिमांड होगा, और दैट ऑप्टिमम पीक के लिए हम जब डिजाइन कर देते हैं तो कभी भी स्केर्सिटी नहीं आती है. लाइक इफ वी से कि किसी भी ईयर का, इफ वी टेक जून मंथ, एंड जून में वी से डे 8 में सबसे ज्यादा वाटर कंजम्पशन है डे 8 में. सो द हाईएस्ट रेट ऑफ वाटर कंजम्पशन आकरिंग ड्यूरिंग एनी 1 आवर ऑफ द मैक्सिमम डे, और ये आकर करता है से 8 to 9 AM मंथ ऑफ द मैक्सिमम सीजन. सीजन क्या है, जून है. सो फॉर दैट वी नीड टू डिजाइन इसका जो कंजम्पशन होगा दैट टाइम इट विल बी जो मैक्सिमम 180% हमने कैलकुलेट किया उससे भी बढ़ के होगा, क्योंकि इसमें सीजनल वेरिएशन भी आ जाएगा, मंथली वेरिएशन भी आ जाएगा, एंड देन आवरली वेरिएशन भी आ जाएगा. कुल मिलाकर के इट विल बी 1.8 into 1.5 into annual average daily demand. So it will be about 270%. We can see from this graph, this is our maximum water demand, that is 180% of the annual average daily demand, and it goes higher than that also, because during that day, that maximum day, there will be for that single hour the water demand will be more than the 180% also, that will go up to 2.70%, 2.7 times of the annual average daily demand. So this is the peak demand. We need to understand कि जो हमारी वाटर सप्लाई स्कीम हो उसका जो एब्सोल्यूट मैक्सिमम आवरली डिमांड है वो कितना है. द हाईएस्ट रेट ऑफ वाटर कंजम्पशन occurring during any 1 hour of the maximum day. मैक्सिमम डे जो डे का मैक्सिमम टाइम है से 8 to 9 AM है, ऑफ द मैक्सिमम मंथ से जून है मैक्सिमम मंथ, ऑफ द मैक्सिमम सीजन इट इज ए समर सीजन. पीक आवरली डिमांड होता आकर होता है, इसके लिए हम लोग को ये डिजाइन करते हैं. इफ वी डिजाइन फॉर दिस पर्पज देन देयर विल बी सक्सेसफुल वाटर सप्लाई.